State the number of sides of each named polygon and the sum of the interior angles. And for this opportunity, we're just going to assume that we have convex shapes. We're not going to talk about concave. And then find the sum of the measures of an interior angles of a convex 17-gon. I want you and your partner to solve for y. And if you finish all that before I call you back, go ahead, flip over onto the back and work on these conversations. So we want to make sure that when you have a warm-up the day of a quiz, your goal is to try it without any resources. And if you can't answer these questions, then you dive into your packet or you talk to your partner. Sitting and not doing work is not an option. Am I clear? Turn to your partner and say, let's go. All right, I want to make sure you're with me on this. Come back to the very front. This formula here that's in red, you should have no problem remembering it because we proved it. Yeah. So if you do struggle with remembering it, go back to what you know. You know a triangle has 180 degrees inside of it, and every triangle you add to a shape adds 180 degrees. That's why the quadrilateral is 360. So if you need to remember this formula, n represents the number of sides, if you put a triangle conversation into it and a quadrilateral conversation, which you already know, that helps you out with this. All right. State the number of sides of each named polygon and the interior angles. This is a vocabulary term. Somebody asked me yesterday, any clues on how to remember this? Yeah, they're your prefixes that your English teachers have been teaching you to pay attention to for years. If an octopus has 8 arms or 8 legs, how many sides does an octagon have? Like the Pentagon is the building that maybe some of your parents work out or that you've driven by. How many sides does the Pentagon have? So a lot of those things should just be a part of your normal language. If not, you need to put some effort into it. Whether we call this a heptagon or a septagon, how many sides are there? 7. When I put this into my formula, I know 5 times 180. And like I said, you have your calculators all the time. So if you want to do this one in your head, rock on. But when it comes to a quiz or a test, a lot of times I don't trust my brain or my clumsy thumbsy. So I'll do it both ways and make sure that I can double check and validate myself. So there are 900 total degrees. If you are talking about degrees, that circle is your units. You will lose a half a point if you don't include your units. Find the sum of the measures of the interior angles of a convex 17-gon. They told me it was convex, so I don't have to worry about being concave, but did they tell me it was regular? No. So I can't find each measure. So find the sum of the measures of the interior angles of a convex 17-gon. All I need to do is put 17 into this and then do 15 times 180. There they are, 2,700. So when I'm talking about figuring this out, if they don't use the word each or regular, you can't assume that it is a regular situation. Is you okay with that? Mm-hmm. All right. For here, when I go to find my values for y, this is a really good reminder that not every shape we're going to be dealing with is regular. So I need to go to my calculator and do some math here. So 130 plus 75 plus 125 plus 145 plus 115. I would validate that and look at my partner and go, did you get 590? Because that's a lot of numbers to add up. Did we get 590? Yeah. All right, so 590 is the sum of the angles that I do know. I counted my sides, 1, 2, 3, 4, 5, 6. So I know that 4 times 180 is going to be my total angles. So 720 live inside of that figure. I'm able to account for 590. So when I do my subtraction, this obtuse angle here has a measure of 130 degrees. You're like, no, that's not the one we're asking for. You're right. But I can't find y unless I know its supplement. Y and 130 are a linear pair. Y and 130 are supplementary. When I figure out 130, that allows me to subtract that 130 from 180 and recognize that y has a measure of 50. Questions on any of those three? All right, let's go to the back. When we look at this conversation, find the number of sides of a regular polygon with an interior angle measure of 140. They went ahead and talked about a regular polygon and with one interior angle. So this is your conversation about each. Each of those angles is 140 degrees. So when I figure this out, I know that my total number divided by each number is going to be equal to that measure. Clark, what's on your mind?
Ours says 40, not 140.
It is different.
So we fixed, we changed the problem, so will you add a 1 and make it into 40? When we copy the quiz, sometimes the back and front, we forget to change one or the other. Thank you very much. Add another Smarty up, Clark. So is the tally the ones that are already there?
No, they're the extras.
They're the extras.
But aren't they already there?
Yeah.
So we erased them and then we filled in those extras.
No,
No, somebody just started to erase it, I think. But then we did.
Alright, I got you. Alright. We're gonna fix that. Lickety-splickety. So when we're looking at this is going to be a conversation for you about can you solve this formula. Number one, do you understand why we wrote it? The sum of the interior angles divided by the number of sides is the measure of each. Each was 140. So step one is understanding what the question is asking. Step two is understanding how that formula represents that answer. The hardest part now comes with the algebra, which you were supposed to have learned last year. Turn to your partner and talk about how to solve for this n. You mark it, set, go. All right, come back. Here's the algebra. Come back. My number of sides times 180 divided by my number of sides. My number of sides plus 2 times 180 divided by my number of sides is equal to 140. It's the measure of each individual angle. My first step is to multiply each side by my denominator, and these n's cancel out, and that gives me 140n on this side. I distribute my 180, and I get 180n minus 360 on this side. I'm going to combine like terms, so I'm going to subtract 180 from each side, and I end up with negative 360 is equal to negative 40n. Be careful of your negatives and make sure you understand those. Dividing each side by negative 40 gives me n has a value of 9. It's a nonagon. Now the conversation is there something else that we can do to solve this? Joey came up and said, I did it this way, it seems to have worked out, but I'm not sure if it's going to work every time. I have a funny feeling that was what was on Evelyn's mind. Because there is an easier way of doing this, but you have to take your brain and maybe expand it a little to think about what you're thinking about. Because what Joey says is if this angle of some shape is 140, doesn't that mean that the exterior angle is going to be 40 degrees? You okay with that conversation? So if the exterior angle is 40, and I know that the sum of the exterior angles is always what? 360 degrees. So if I know that my sum of my angles is 360 degrees, and I'm going to divide it by each one is 40, doesn't that give me a 9-sided shape? So whether you use an interior conversation or an exterior conversation, understanding this interior-exterior relationship might make the problem easier for you. So sketching it out and drawing a picture is something I 100% recommend. Everybody okay with that? Awesome. Maya gives me a thumbs up. So we have a 9-sided shape. N is equal to 9. Moving on. When we talk about what values of x and y will make the quadrilateral a parallelogram, when we talk about if it's a parallelogram, these diagonals bisect each other. And you have to think about what that means. Nobody said that those diagonals were congruent. Everybody knows in a parallelogram, chances are you have one short diagonal and one long diagonal. Here's my short, here's my long. So the diagonals are not always guaranteed to be congruent, but what they are guaranteed to do is chop each other in half. That's what bisecting means. Break it exactly in half. So if I break this exactly in half, the two equations I can write from it are 6x equals 72 and y is equal to 5, or x minus 5. It's obviously easier to solve for this x here by dividing 72 by 6. And then placing this value for x into here to know that y is equal to 12 minus 5. So y is going to be equal to 7. So those systems of equations, sometimes we can match and write an equation with the same variable and solve it. That's easy. Sometimes we need to embed one into another. That's the way it goes. We okay with that? When we talk about the 6 methods to prove a quadrilateral is a parallelogram, this is how my brain works. So you do you, but the absence of a system is not a system. So if you don't have a system, it's time to get one. To me, I always start off with the definition. What is the definition of a parallelogram? 2 sets of opposite what? That are, yeah. So 2 sets of opposite parallel sides. So by the definition of parallelogram, Euclid says if it's a parallelogram, it has 2 sets of opposite parallel sides. If it has 2 sets of opposite parallel sides, it's a parallelogram. That's a biconditional conversation. We can read it forwards and backwards. It's always true. This is what it is. Definition. Are we good with that? We can take that definition, and we were able through congruent triangles and CPCTC to say if I have 2 sets of opposite congruent sides, it's also going to be a parallelogram. So I go, when I'm talking about my sides, I talk about parallel, I talk about congruent. To me, it makes sense to talk about sides all at one time. While I'm talking about segment length, I'm going to go ahead and move on to my diagonals and say that a parallelogram has bisecting diagonals, which we just used in the problem above. Now comes the 2 conversations about my angles. I know that I have 2 sets of opposite congruent angles, and I know that my consecutive angles are supplementary. So those 2 angle conversations are kind of infused together. This last one is the one where I have to make sure that I'm very, very careful, because I need one set to be both parallel and congruent. And I'm going to be super careful that I don't mix up a trapezoid, because a trapezoid has one set of sides congruent and the other set parallel. And that is not a parallelogram. So if I want it to be a parallelogram, both sets, both have to be true. I have to have my sides that are parallel also congruent. I don't want it to be a trapezoid. Are we okay with that? Yes.
That's only 5.
1, 2, 3, 4, 5, 6.
Oh.
Are we good? Alright. I asked you to do your quiz review, and I put the key on Schoology. So if we open up that, if there's any questions from your homework that you, in your travels, were curious about, I'd be happy to answer them for you. Let's start with page 1. Determine whether the figure is a polygon. If not, explain why. If so, identify it as concave, convex, and name it by the number of sides. Any questions on 1 through 6?
No.
7, use the diagram. Name the polygon. And when we talk about the polygons, just ring around the rosy. Nobody cares if you go clockwise or counterclockwise when you name that polygon. Just as long as you do ring around the rosie's vertices. Name all the diagonals that have E as an endpoint, as long as it's not the sides. Can't be EF and ED. Name the non-consecutive angles to angle A. The angles that are consecutive to A would be G and B. Everything else is non-consecutive. So C and D and E and F. For 11 through 14, the sum of the measures of the convex sextagon. Solve for X in this figure. The measure of each interior angle is 162. How many sides does polygon have? You can cheat and do this one the same way that we did that first one. 162 is supplementary with 18, right? And then 360 divided by 18 is 20. So you can get your answer 2 ways. Deal with the interior or exterior angles, your choice. The measure of each exterior angles is 6. How many sides? In 8.2, solve for the given variable. So when we look at each of these parallelograms, your justification, you were able to solve for y because opposite sides in parallelogram are congruent. You were able to solve for the angles and the side and consecutive angles are supplementary, opposite angles are congruent, and diagonals bisect. So that's your justification given, look at the directions, given that it's a parallelogram. 8.3, are you able to determine whether or not the quadrilateral is a parallelogram? This is about proving it. So, yes, I have one set of sides parallel congruent. Yes, my diagonals bisect. Yes, 2 sets of opposite sides are congruent. No, because I don't know about this side. This could be a trapezoid. Yeah, yes, because the alternate interior angles are going to give me 2 sets of parallel lines. And yes, my opposite angles are congruent. And here's my consecutive supplementary angles. For 7, 8, 9, and 10, determine what information you need. If I have one set of parallel lines, I either need that set to be congruent or the other lines parallel. If I have one set of congruent lines, I need that set to be parallel or the other set to be congruent. If I have those 2 angles congruent, all I need is the other sets parallel. These are congruent, I need these to be congruent, and then my consecutive supplementary angles help me out with 11. For 12, 13, and 14, finding the values of x to guarantee they're a parallelogram. So lots of algebra here for you. I need x to be 60, y to be 30 for 12. I need 15 to be y and x to be 5 for 13. 14, a little bit of fraction work here. Y has to be 31/7, x has to be 620/7. And 15 was a system of equations. X is equal to 3, y is equal to 5. For 17, in 16, 17, and 18, we proved that it was a parallelogram by saying the slopes are the same, therefore the lines are parallel, therefore it's a parallelogram. we went ahead and said our distances were the same. Therefore, the segments were congruent. Therefore, it was a parallelogram. 18, I found my slopes were the same, of the same side, the distances were the same, so therefore it was a parallelogram because each were congruent and parallel. Which method did you prefer? Most kids choose the one with slopes. Thumbs up if you pick slopes. Thumbs up if you pick the one I did. I always like picking one side because when I figure out those change in y and change in x's, that applies to both slope and distance. It feels like less work for me. Asking you to finish the proof. Given those angle measures, prove it's a parallelogram. I think your one that we did is a little bit different. We added a statement of given. Yeah, we updated it because we were missing the given. But the sum of the measures of quadrilateral are 360 degrees. We can do combining like term and factoring. X and Y are going to be 180 degrees. Definition supplementary says that they are supplementary. Then I get some converse consecutive interior angles proving that they are parallel, and therefore it's a parallelogram by definition. Are we good? Awesome, cleared us. So if you find this page in your packet, I want you to take one set of shapes. If your partner already has them cut out, you're welcome to share their shapes. If you're just picking up yours now, it's up to you. But what we want is for you to look at each of these sets of shapes, loosely cut them out, and then we want you to sort them according to what these characteristics say. So when you look here, if you're listing the pieces by letter of each of the shapes that appears to have 4 right angles, and I'm okay with you going by the picture on this example. I'm okay with you saying, well, this one looks like this, or this one looks like that. So listing all the numbers that have 4 right angles, sorting them out, and then what we want is for you and your partner to think about some prior knowledge, some background stuff, some 3rd, 4th, 5th, 6th, 7th, 8th grade geometry. Tell me what you think we call these shapes. Do you know the vocabulary term for this type of quadrilateral? So the idea here is conversation and chatting. So if you need to turn to your partner and say, do you need a minute to catch up? Go ahead and do that. If your partner just started cutting, you can say to them, you know what, let's just use my shapes, that's fine. You can share, but I want you working together on your market set, talk, and sort. Go. Just of time, we're going to go ahead and scoot through and look at, when we look at each of these shapes that you have, and how we go ahead and sort and recognize their characteristics. When we list them by letter, what you end up with is an interesting conversation, and this is going to be today's lesson in talking about these terms that I'm hoping you already know. The ones that I want to make sure that we point out is this is already a conversation about one of our 6 things we memorized about parallelograms, as is number 5, as is number 9, as is number 12, as far as when we're looking at those features of a parallelogram. Do me a favor and scoot forward in your packet to note 7.4. So hopefully a lot of this is a review for you, but we need to go ahead and tease out some interesting things about quadrilaterals that maybe you haven't thought to consider yet. We're going to talk about rhombuses and rectangles at the same time. They are all quadrilaterals. We're exploring additional quadrilaterals, 4-sided figures. And what we're going to notice is many of these are also parallelograms. So the rhombus and the rectangle and the square are all parallelograms. So they're all going to also contain all the parallelogram properties, those 6 that we already talked about. In addition, we're going to talk about a rhombus is an equilateral parallelogram where all of my sides have the same length. My rectangle is going to be my equal angular parallelogram where all of my angles have the same measure, and we know that measure is 90 degrees. We're going to introduce some interesting conversations about the diagonals. And the diagonals have some different characteristics that we want to make sure that you pay attention to. If I draw my diagonals in my rhombus, they will always intersect at a perpendicular angle, 90 degrees. The diagonals in a rhombus are also going to be angle bisectors. Now they're not the same measures consecutively, but we can recognize that the opposite angles that are congruent, they're both bisected the same. Those diagonals create those triangles, and we can prove that the different values of congruence in CPCTC because my sides have the same length. So all of these triangles are all congruent. They all have diagonals that correspond. They all have a triangle where the legs of the triangle are either the short or the long diagonal. They all have a hypotenuse that's the same. So all those corresponding angles create those cool relationships. A different story happens in a rectangle. My diagonals, yes, they bisect because it's a parallelogram, but it's not at a right angle, and they do not bisect my angles. The only thing that's true about these diagonals is that they are congruent. And they create, again, rectangles or triangles, but see, these triangles are congruent, left, right. These triangles are congruent, up, down, but they are not all 4 congruent like they are in this shape. Everything that we understand about rhombuses and rectangles is combined in our conversation about a square. A square is our regular rectangle, our regular quadrilateral, and because it's regular, we know that the equal angular and equilateral properties apply. Same with everything that's true about a parallelogram. Opposite congruent sides, opposite congruent angles, consecutive angles are supplementary, bisecting diagonals. But both of the conversations about the diagonals from the rhombus and rectangle also apply. Those diagonals are perpendicular. Those diagonals are angle bisectors. Those diagonals are congruent. So, talking about nested diagrams, the interesting thing is when we talk about what is the subset of something else. A square is the most specific and special kind of parallelogram. Rhombuses are sometimes squares. Squares are always rhombuses. So we go back and forth between that sometimes, always, never relationship and conversation. If you flip over to the next page, we have 2 different diagrams. One is a nested diagram and one is a flow chart. So when we talk here about parallelograms, we know that special kinds of parallelograms, if it's equilateral, we call it a rhombus. If it's equiangular, we call it a rectangle. And if it's both things, we call it a square. That's where those shapes fit into that conversation in our flow chart. If you look at the top of your page where you have this nested diagram, we understand that our parallelograms are going to be this subset of our quadrilaterals. We can talk about shapes that are equilateral and define them as rhombuses. We can talk about shapes that are equiangular and define them as rectangles. And then we can talk about our squares as being that center of the Venn diagram, having all of the properties. So whichever makes the most sense to you, whether we're talking flow chart or nested diagram, you want to make sure of those relationships. So if we're talking about all kinds of four-sided shapes, we're talking about all of our quadrilaterals, and you can see we've got three other conversations to have that are four-sided shapes, and these are shapes that are not parallelograms. So we'll come down here and talk about these three shapes. I was in a math class one time where we argued for over 30 minutes about the definition of a trapezoid. Exactly one set of parallel sides. The minute that two sides are parallel, it's now a parallelogram.
I don't have that. Oh wait, no.
So on your first page of notes, there you go. So making sure you understand some trapezoid vocabulary, bases and legs. Your bases are always going to be your parallel sides. Your legs are the non-parallel sides. If you have an isosceles trapezoid, your bases are parallel, but your legs are going to be congruent. If you have a right trapezoid, you have one right angle. So we can draw what each of these looks like. Here's my parallel sides. Here's my right trapezoid. If I have an isosceles trapezoid, I'm going to have two congruent legs, and these base angles are going to be congruent. Isosceles trapezoids also have congruent diagonals. In all trapezoids, we can draw a mid-segment, which you know what that is from our triangles. And that mid-segment is going to be the average of the base length. So base 1 plus base 2 divided by 2 is our average. A kite is going to be a quadrilateral with two sets of consecutive congruent sides, and our diagonals in a kite will always be perpendicular. And a dart is what we call a concave quadrilateral. Think of it as something that's been punched or dented in. That's that concave, we call it a dart. The next couple pages have practice for you to do, and there will be a delta math for you to do. Hopefully you are not falling behind on your delta maths. We'll talk more about this sorting chart when we get together next, and each of these things. If you can return your scissors, and if you want a paper clip for your sorting pieces, I will have one for you. If you want to toss your pieces in the trash, that's fine too. Oh. Where's mine?